How are you, everybody who is watching this video? This is Olenjolai Mokota Yailo Single from beautifully fantastic country known as United Republic of Tanzania, and this is our national flag. So I love my country. I ask you also to love your own country. Okay, I would like to welcome you into this fantastic official YouTube channel called Tanzania Online A-Level Secondary Schools in square bracket Olenjolai M. A-Level, this is the short terms of advanced level. So this is an online advanced secondary schools. It's not a physical, it's online. It's not analog, it's digital. So I want to give you a little introductions about this channel. What are we doing? So the main visions of this channel, we are helping students to learn advanced physics, advanced chemistry, advanced mathematics, and basic applied mathematics in a very unique way, and in modern and fantastic and even in high definitions of learning. So that's the main visions of this channel, and make students to love science, to love physics, to love chemistry, to love mathematics, to love basic applied mathematics, because it happens that they don't like it because of the challenges they encounter during the year A-level studies. We have 7 departments in these online schools, or online secondary school, online A-level secondary schools. The first one is advanced chemistry, advanced mathematics, and the other departments is advanced physics. But today you are enjoying the stuff from advanced chemistry, where you will learn 7 advanced topics for Form 5 and Form 3. The main topic that I'll be teaching you today is called general chemistry, and then the topic or the chapter is called the atomic structure, because general chemistry, it has 2 topics: atomic structure and then chemical bonding. This class, this material is for the Form 5 or pre-Form 5 or Form 6 or ordinary diploma who are studying chemistry as one of the year modules. And then this is lecture or session or period 15. It means that I have already taught lecture 1 to lecture 14. You make sure that you go through before you come, because this is a progression or continuation of the previous lecture. Another thing which I want to say before we go to the subject of the day, I would like to just to say, in case or if you feel from your heart, just like myself, I felt from my heart, and I offer my thanksgiving to God on the gift of teaching that He gave me by teaching you this material free of charge. So in case even yourself that you feel from your heart that you want to offer thanksgiving or the thanksgiving offering or seed offering to God through this program, you may use a mobile transactions, which is M-Pesa, by using this number, +2 5557 5974 5331. In case that you're international students, read the descriptions of this video, and then you'll find how you can do bank transactions and even mobile transactions. You'll get too much details on the descriptions of this video. So if that's the case, that's all about the introductions, which is very important. Now let us go to the business of the day, which is called the principles of electronic configuration. Say, principles of electronic configuration. In some of the books, they write rules of electronic configurations, rules of advanced electronic configuration. So let me add this way, because we learned ordinary or fundamental electronic configuration in all levels. So rules of advanced, this is a little bit advanced electronic configurations. So we have 4 rules which we have to remember when we are writing advanced electronic configuration in elements of of periodic table. So I will be teaching you each law or each principle, and then see how does it affect the electronic configuration. Remember that also we need the concepts of orbitals, very important. It means the concepts of quantum number is very relevant for you to understand what am I going to teach you, right? So in case you see some of the stuff are complex for you, it means you jumped, right? So don't jump. Okay, so this program for the serious students and these lectures for the serious students, and I'm a serious teacher, so make sure that you should be serious, take all the resources required for learning, for the serious students, and then let us go to business. Good. So let us start. So the first fundamental question that we have to ask ourselves on this concept, before we go to the principles, let us ask yourself, what is the meaning? What is the meaning of what the meaning of the word of electronic configuration, right? What does it mean? Or in some of the books, we can ask you that define electronic configuration. What will you say? How will you define? Is it a complex term for you? No, it's not complex term. So let us define. There are various reference books define the concepts of electronic configuration, but I came with one of the definition, which is general definition, and can suit you anywhere when we be asked to define electronic configuration. Say electronic configuration again. Okay, so electronic configuration is a particular arrangement, arrangement. So this is a particular arrangement of electrons in different orbitals. That I taught you in the quantum number orbitals of an atom. This is the definition of electronic configuration. Is a particular arrangement of electrons in different orbitals. When I have been teaching you about the concepts of quantum number, we say that how many quantum numbers are there? 4 quantum number. Principal quantum number, subsidiary quantum number, magnetic quantum number, and spin quantum number. So when we learn the subsidiary quantum number, it's a quantum number. Tell us about the orbitals we can find in the shell of an atom. And there we've learned 4 fundamental orbitals: the s orbital, the p orbital, the d orbital, and the f orbital, right? In magnetic quantum number, we call them sometimes orbitals, but it's a mistake to call them orbitals. The correct name, we call them sub-energy levels. The principal quantum number is the energy level. The subsidiary quantum number, this defines the sub-energy level in the main energy level, right? So it means that these are the subsidiary. It means that these are sub-energy levels. So we have S sub-energy level, we have P sub-energy level, we have D sub-energy level, we have F sub-energy level, right? When I taught you about the magnetic quantum number, and then I taught you that one of the applications of magnetic quantum number is determine number of orbitals in each sub-energy level, right? So you found that the s orbital has how many orbitals? Only 1 orbital. The p orbital has how many orbitals? 3 orbitals. Px, py, pz. The d orbital has how many orbitals? 5 orbitals, right? And then the f orbital, the f sub-energy level has how many orbitals? 7 orbitals. So now, when I told you about the last quantum number, which is called spin quantum number, and then we told you that spin quantum number dealing on filling electrons in the orbital, right? So now, so what the issue about electron configuration now? We say that we should, the electrons, according to the research and experiments that many chemists have done, they found that the electrons have particular arrangement. It means that the electrons within an atom, they don't arrange themselves the way we think, right? So you have to learn how they do arrange themselves, and even what do we expect you to find when we are doing maybe the experiment of atomic structure. So that's why that we call that electron configuration is a particular arrangement of electrons in different orbitals of an atom. An atom has a energy level, right? Now, an atom has nucleus and shell, right? And shells has different energy levels, okay? And because that an atom has different energy levels, then what happens? The energy levels also, or one energy level has different, might have different sub-energy level, right? And then the one sub-energy level can have different orbitals. And then in the orbital, we used to fill electrons, right? So the process and the particular arrangement or the arrangements of electrons is what we call the electronic configuration. Okay. So there are three principles or rules which are used to write advanced electronic configuration, but there are the other fourth one which is also important but is not insisted to a lot, but it's better if I teach you. So we say that there are, types, okay, there are four principles that are used to write the advanced electronic configuration. These four rules, the first one, we call it alpha principle. Okay, we call it alpha's principle. And then the second one, we call it Hans rule. The third one, we call it Paul's exclusion principle. Paul's exclusion principle. And then the fourth one, we call it the full and half rule. Full and half rules or rule. So these are the four principles that we have to follow on writing advanced electronic configuration to advance what we knew, right? Okay. This is called the full and half. It's called the full and half what? Let me check contradictions. Full and half full. No, full and half full rule. Full and half full. So this is called the full and the half full rule. Full and half full rules. So I will be teaching you each principle and see how does it affect the electronic configuration. Let us start with the first principle or rule we call the alpha bar principle. Say alpha bar principle. Alpha bar principle. Okay? Alpha bar principle. So the first principle I'm going to teach you is called the alpha bar principle. Alpha bar principle. Right? Alpha bar principle. Before we state the alpha bar principle, or say that, or let us go straight for the question is this one. State, in many exams they used to ask you this question, state the alpha bar principle. The alpha bar principle, or the alpha bar rules. State the alpha bar principle. So this is the way that is stated. We say that the alpha bar is a German alpha bar. State the alpha bar. There's a U I forgot here. And even this the German chemist. German, this is the German chemistry. So we call it the Aufbau principle. State that, very interesting principle. State that, I would like to quote, it is, in the ground, so you say in the ground state, in the ground state, electrons tends, so electrons tend to occupy the orbital with minimum energy. This is the end of alpha principle. So alpha, before I explain to you what does it mean, suggested that according to this principle, alpha suggested that the electrons are lazy. So electrons are very lazy. Why they are very lazy? Because they tend to occupy the minimum or the orbital with minimum energy. So if they are not lazy, it means they tend to occupy what even the orbital with what is maximum energy. So the principle state that before I explain what it means of the word alphabet in German, this principle said that in the ground state, say ground state, in the ground state, okay, in the ground state of an atom, electrons tend to occupy the orbital with minimum energy. Right? So when you say about the ground state, I want just to clarify, we mean that, remember that I told you the hydrogen spectrum, from the concepts of hydrogen spectrum, we had the ground state, we had some other higher energy levels. So this is, when n is equal to 1, this we call the ground state, because this energy level principal quantum number is near to the nucleus of an atom. And then this is not a ground state, this is, we call it excited state. And this also it is excited state. This n is equal to 4 excited state, n is equal to 5 excited state, etc., etc. So this is the lower energy level. So in the ground state, we say that electrons tend to occupy the orbitals with minimum energy. If you remember the formula also that we derived it together in both, that the energy or the change in energy, okay, in particular energy level is given as negative 13.6 electron volt over n squared. And realize that these are the lower energy levels. So this has the lowest energy level compared to this, etc. Because we say that as we go up, mean that the energy increases. So according to Aufbau's experiment, he found that electrons in the ground state tends to occupy orbitals with minimum energy. So what the meaning of what? Of the word Aufbau in German. So we said that Aufbau in German, or Aufbau is the German word meaning building up or constructions. Hence, Aufbau principle is also known as building principle. Okay? So in German, the word Aufbau, the word Aufbau means building, right? Building up. Okay, building up or construction. or construction. So if you say that I alpha my house, means that I'm building my house, right? Hence, alpha alpha principle is also known as building. Say building. Building what? Building principle. Building principle. Building principle. At the meaning of 40 of Baha principle. So it means building principle or construction principle. But in Alpha, we are not constructing the houses or roads, we are constructing the electronic configuration. So let me take an example to show you how Alpha principle works before I give you the general tendency of Alpha. So when electrons are added to an atom, they will go to any available lowest energy. So you say that according to alpha, according to alpha or building principle, right? According to alpha principle, say that when electron is added, when an electron is added, when an electron is added, or when electrons are added, so when electrons more than one electron, when electrons are added, okay, when electrons are added to an atom, electrons are added to an atom, when electrons added to an atom, they tend to occupy the available lowest energy level. Lowest energy level. Lowest energy level before occupying to the highest energy level. So according to the alpha principle, when electrons are added to an atom, right, they tend to what? To occupy first or to fill first the available lowest energy level. The available lowest energy level. So it means that if you have the available lowest energy level and you have the available highest energy level, then the electrons prefer to occupy the lowest before the highest. Right? So before I teach you the the alpha electronic principle, I think that's the best thing. Then after teaching you, I will give you some examples. Then it will help you to understand. Okay, so the next concept said that the order of electronic configuration according to alpha. So let me teach you the part that say the order, the ascending order. Ascending order of what? Of advanced electronic configuration. Electronic configuration according to Aufbau principle, according to Aufbau principle, or according to the building principle. So he said that Aufbau arrange the orbitals in ascending order according to his principle or to his rule. So let us see how did he write this principle? How did he write this configuration? So the order, the ascending order, you have to stop writing if you are writing, and then concentrate on what am I going to write to you, because it's going to be helpful for the rest of your life in chemistry. So stop writing. So this we call it alphabet electron configurations order. So we have always remember that the principal quantum, the first principal quantum number is 1, right? So listen carefully. We want to write in this form. So let us start with the first sub-energy level is what? S orbital, right? So S orbital. And then here we are going to have D orbital. Listen carefully. And then so we are going to have what? This is P orbital. Excuse me. So let me write again. We are going to start with S orbital. And then in this column, we are going to have what? The P orbital. And then the next column, we have D orbital. And then the last column, we have D orbital. Or D sub-energy level, that's what it means. Okay. The first principal quantum number is 1. We do have 1s, right? Also, we do have 2s in some of the electrons, some of the elements. We do have 3, so let me just leave the space because we draw something there, some lines. We do have 2s. Also, we do have 3s. We do have 4s. We do have 5s. We do have 6s. We do have 7s. Listen carefully. I said stop writing. Listen careful. Follow along. According to quantum number, we don't have 1p orbital. It's not there. It does not exist. So we used to find the p orbital when we have the principal quantum number is equal to 2. So we have what? 2p orbital. Okay, this is the principal quantum number. And also we have 3p orbital is there. Also we have 4p orbital. And also we have 5p orbital. And also we have 6p orbital. And also we have 7p orbital. Right? According to the quantum number that I told you, when you come to the column of D, we don't have D orbital in principal quantum number n is equal to 2. We used to find the D orbital in principal quantum number n is equal to 3, right? So it means that our D orbital will start here. 3D orbital, then we have 4D orbital, then you have 5D orbital, then you have 6D orbital, then you have 7D orbital, right? Again, according to the quantum number that I told you, we don't have 3, we don't have 1 F orbital, 2 F orbital, 3 F orbital. We used to have F orbital when the principal quantum number is equal to 4. So it means that here we are going to have 4 F orbital, 5 F orbital. However, that Don't think if it will exist there, but there is 6 f orbital, but it's rarely, and even there is 7 f orbital. That's the first process. Listen carefully again. Okay? So now we have arrangement of orbitals of the 4 fundamental orbitals: s orbital, p orbital, d orbital, and f orbital. And we arrange them with principal quantum number as their coefficient. We are not filling electrons yet. We want to arrange first the orbitals. How do we arrange these orbitals when we are writing advanced electronic configuration? So listen again. So Aufba said that this is the way that you have to write its electronic configuration. Listen carefully. So the electronic configuration starts always with 1s, like this, right? And then you should not go this way, but you have to turn up to the point where you started. Then we go to this point. So this is in this direction. So we reach at this point, then we turn. Then we go. Please, please, please stop writing. Right? Then we pass by this one. This is the direction. Then we turn. Again we go here. This is the next direction. Right? And then we turn. Then here we are. And we write this. Right? So this is the direction. And then we turn. Then we come. We pass these subenergy levels. This is the direction. Then we turn. We pass these subenergy levels. Right? In this direction. Then we turn. We pass these subenergy levels. If they do exist, up to 8s. Right? And then we turn. That's how the business going on. And that's the beauty of what? Aufba principle. You like it? Yes, you do. For me, I don't like it. So with this now arrangement, or with this order, do you see? Let me repeat. I repeat for you, for the benefit of students so they understand. I say that we start at this point. This is the starting point, right? So we pass this sub-energy level, then we turn. We don't go this way, don't make a mistake, then we turn. We come at this point, then we go through this, then we turn. We pass at this point, we pass these 2 orbitals, 2 orbital and 3s orbital, then we go. We pass 3p orbital and 4s orbital, then we turn. We pass through 3d orbital, 4p orbital, then 5s subenergy level, we turn. We pass through 4d subenergy level, we got the 5p subenergy level, we got the 6s subenergy level, then we turn. Then we got the 4f subenergy level, we come to 3d subenergy level, we got the 6p subenergy level, we got the 7s subenergy level, then we turn. We pass through 5f subenergy level, we pass through 6d subenergy level, we pass through 7p subenergy level, then 8s subenergy level, and then we turn. So you continue as well as you can. So if you come back again, you go this way. So that's the business, and that's how we write the ascending order 40 Aufba principle. I believe that you have understood it clearly, even if that you tried several times to go through or to follow what your teachers taught and you failed. I believe that now you have revelations concerning about this stuff. So I'll be taking you slowly, right? So that is the first step. So let us say that this is the first step. But when we are writing the electronic configuration, it means that we say that line, this is line ascending order. Ascending order. So basically, we don't write electronic configuration by following this or by drawing these lines, but we need that arrangement because we should know in our mind before, or when we are writing electronic configurations, when you are writing advanced electronic configuration. If you have any questions, don't hesitate yourself to ask in the commenting sections, and then we'll meet together there and discuss the beauty of general chemistry and the beauty of advanced chemistry. So listen, stop writing, stop writing. Okay, because I love you and I want you to understand. The second state now, this is the way that we can memorize, right? So it means that